Welcome to The Explainer. We're diving into why modern wind farms can sometimes cause dangerous grid oscillations.
So why does this happen? The short answer is a tricky phenomenon called resonance instability. Let's unpack it.
All right, here's our game plan. We'll look at the problem, the components, the math, a case study, and the root cause.
With more wind power comes a new headache: complex oscillations across a huge frequency range that threaten grid reliability.
It all boils down to resonance stability. And the instability? It often points to the Type 4 wind generator.
Now, its converter gives it incredible control, but it also creates some, complex electronic side effects.
For these high-frequency wobbles, we zoom in on the grid-side converter and its control systems.
A voltage disturbance creates this cascade effect through the control loops. How it responds, that's everything.
When you got multiple farms interacting, a simple impedance model just won't cut it. We need something bigger.
So we bring out the heavy artillery, the S-domain nodal admittance matrix method. It models the whole system.
This is the magic equation. If its solution has a negative damping coefficient, the oscillation will grow, not die out.
Okay, let's put this to the test. Here's a case study on a real system with 16 Type 4 wind farms.
The results are pretty clear. They found two resonance modes, one stable, but the second one, it's unstable.
So, let's zoom in on that unstable mode, 77.1 Hz. What's actually going on here to cause this? To find the root cause, you have to compare the impedance of the grid with the impedance of the generator.
And these two charts tell the whole story. The grid's resonance peak lines up perfectly with the generator's negative resistance zone. This is the core problem, a negative resistance effect. The converter actually injects energy, amplifying the oscillations. So the grid has a natural resonance point, and the generator's own effects just happen to hit that exact same spot.
So the big takeaway is that the generator's own electronics are creating this unstable resonance mode.
This leaves us with a huge question. As converters take over the grid, how do we engineer for future stability?